Welcome to the ultimate JEE explainer. Look, complex numbers usually seem super intimidating, right? Just a bunch of abstract equations that don't seem to make a lot of sense. But today, we're going to totally transform them into a logical, highly applicable toolkit. If you're looking to actually ace the JEE main and advanced exams, you are in the exact right place. We're going to break this whole thing down visually so it really clicks.
Here is our game plan. We're going to treat this entire explainer kind of like a video game. We'll start with the birth of iota, learn the rules of complex algebra, and then visualize the Argand plane. After that, we unlock some serious power-ups with de Moivre and unity roots before facing down geometry boss battles armed with your ultimate JEE cheat codes. Let's get into it.
All right, level 1, the birth of iota. So, to kick off our game, we have to confront a massive mathematical wall. What actually happens when x squared equals -1? For the longest time, mathematicians just hit a dead end right here. I mean, you know the rule, no real number multiplied by itself can ever give a negative result. It's supposed to be impossible. Well, this exact roadblock is what forced us to invent a totally new mathematical dimension.
And the solution? It was brilliant. They just invented a new number, I, or iota, which is defined as the square root of -1. Suddenly, boom, we extend our reality into the complex number system. So, a complex number is written as z equals a plus ib. Here, a is your standard real part, and b is the imaginary part. Both a and b are just normal real numbers, but the second you attach that little I to the b, you completely unlock an entirely new dimension of math.
Okay, ready for our first hacker trick for the exam? The powers of iota actually repeat in a perfect continuous 4-step cycle. I, -1, -i, and 1. Why does this matter? Because if you need to find some massive power, like say, I to the power of 25, you absolutely don't need to panic. All you do is divide the exponent by 4 and just look at the remainder. A remainder of 1 gives you I, 2 gives you -1, and so on. It is a literal instant shortcut.
Moving right along to level 2, rules of complex algebra.
Now that we're hanging out in this complex dimension, we've got to learn the physics that govern it. The absolute golden rule for addition, subtraction, multiplication, and division is to just keep things organized. You group the real parts together and you group the imaginary parts together. Addition and subtraction, super straightforward. Multiplication takes a little bit of algebraic expansion, giving us a new mixed output. But division? Well, division requires a really special trick using something called the conjugate.
Let's see this division trick in action by simplifying a fraction. Step 1, you just simplify the numerator. Easy enough. Step 2 is where the magic happens. You multiply both the top and the bottom by the conjugate of the denominator. What's a conjugate? You literally just flip the sign of the imaginary part. Doing this beautifully cleans up the denominator, leaving us with a nice, clean final result of -1 plus I.
So here's the crucial takeaway. Really understanding the conjugate, known as z-bar, and the modulus, which is just absolute z, representing the literal physical distance of the number from 0, is what unlocks all these fundamental simplification properties. Knowing that z times its conjugate equals the modulus squared, that is absolutely essential for saving time on the exam. Oh, and definitely keep that triangle inequality formula in your back pocket. Examiners love using it for trick questions.
All right, level 3, visualizing the Argand plane.
It is time to transition from pure algebra to actually seeing the matrix itself. When we plot a complex number on a 2D Argand plane, the x-axis acts as our real numbers, and the y-axis is the imaginary ones. The angle your plotted point makes with the positive real axis, that is called its argument. And depending entirely on whether your point lands in quadrant 1, 2, 3, or 4, you just use these specific formulas to find your angle, which we call theta.
Finding that angle is a total game changer because it bridges two totally different realities. On one side, we have our standard algebraic Cartesian form, z equals a plus ib. But on the other side, we unlock the incredibly powerful polar and Euler forms. By taking our modulus r and our argument angle theta, we can rewrite that exact same number using sine and cosine, or even more beautifully as r times e to the power of I theta.
And this exponential form leads us straight to Euler's identity. E to the power of I pi plus 1 equals 0. Guys, this is an absolute legendary must-know for the JEE. I mean, think about it. It beautifully connects the 5 most fundamental constants in all of mathematics, E, I, pi, 1, and 0, into one simple, elegant equation. It's honestly a mathematical masterpiece.
Let's keep leveling up. Level 4, de Moivre and unity roots. Okay, time to grab some power-ups so we can handle massive exponents without breaking a sweat. First up is de Moivre's theorem, which is an unbelievable shortcut. It proves that if you want to raise a trigonometric complex number to an integer power n, you literally just multiply its angle by n. That's it. Instead of filling up pages with painful algebraic expansion trying to calculate something to the power of 10, you just multiply the internal theta by 10. It is going to save you so much time.
And speaking of essential power-ups, you absolutely have to memorize the cube roots of unity identities. 1 plus omega squared equals 0, and omega cubed equals 1. Seriously, I cannot stress this enough. These specific properties of omega show up in at least one JEE question every single year without fail. Burn these formulas into your brain right now.
We are making great progress. Level 5, Geometry and Locus Problems.
Armed with all the tools we just gathered, we are finally ready to face the boss battles. Now, for JEE Advanced, the rotation formula is your ultimate secret weapon. See, when you multiply a complex number by e to the power of I theta, it is not just some random algebraic step. It literally represents a physical anti-clockwise rotation on the complex plane. Getting your head around this concept is the absolute key to solving those crazy complex triangle geometry questions they love to throw at you. Let's actually tackle a classic locus problem together, so you can see what I mean. Whenever you face an equation like the one shown in Step 1, whatever you do, don't panic. The universal strategy is, Step 2, just substitute z with x plus iy. Then, for Step 3, you expand the whole thing out and simplify. By turning it back into normal x and y coordinates, you quickly peel back the math to reveal the hidden geometric path. In this case, our complex equation beautifully simplifies to just x equals 0, which we know is simply the imaginary y-axis.
Now, if you want to speed up these boss battles even more, memorize this table of common locus conditions. If you have these locked in, you can instantly recognize the underlying shape just by glancing at the equation. Modulus of z equals r, boom, that's a circle. Modulus of z minus a equals modulus of z minus b, that's a perpendicular bisector. Instantly recognizing these patterns gives you a massive advantage over the students who waste time trying to calculate it all from scratch.
We made it to the end. Level 6, JEE cheat codes and traps.
Welcome to the final level of our explainer. Let's rapidly break down the absolute golden rules you need to survive exam day. Rule number 1, always convert to polar form when dealing with large powers or roots. 2, use conjugate multiplication to rationalize any complex fractions. 3, like we just practiced, for locus problems, substitute z with x plus iy. And lastly, remember that multiplying by the exponential form e to the I theta is your ultimate shortcut for anti-clockwise rotation. But you absolutely must be aware of these common traps because examiners love testing them. First off, never multiply two negative square roots together directly. You have to convert them to I first, or your sign will be completely wrong. Also, keep in mind that the square root of I squared is the modulus of I, which is positive 1, not negative 1. And crucially, remember that the principal argument range is strictly bounded between negative pi and positive pi. Do not fall for the trap of selecting answers outside that specific range. And that brings us to the end of our explainer. As you head off to absolutely crush your practice problems, I want to leave you with one final thought. Given how perfectly these complex numbers model rotation, complex geometry, and even advanced real-world physics, is imaginary the worst possible name for a mathematical dimension that is so undeniably real? Keep exploring, and good luck.